When you are ready to begin the presentation.
Hello and welcome to Claigan's webinar on excerpts from our Claigan updates. So what we're doing today is once a year, we get together and we do excerpts from our normal monthly or quarterly update service. So this is similar to what a lot of our clients get. Usually the more regular version is more interactive. So there's an emoji of me there. That's supposedly what I look like in emoji form. It's a new world these days. Always something new in this online piece. So today's webinar is really based on one of the services we offer all the time. It's about 60 plus companies we do this regularly for, where it's a quarterly or monthly update where we sit down with you and have a web meeting. But the difference between today's and the normal service is the normal service is much more interactive. Your mics are unmuted. You ask questions. We go back and forth. It's really specific to your products and your questions. Today you can ask questions, but they'll go into the questions window, and I'll try to get to as many as possible at the end. It's not quite as interactive, but you basically see what we normally talk about. One of the most fundamental rules of restricted materials compliance are things you're most likely to be non-compliant for, the things you didn't know about. And this focuses very much on keeping you up to date in a very tangible way. So you sit down once a month or a quarter, and we talk about the changes and not just the regulatory, but also the technical details. A good portion off the start today, we'll be talking about the new REACH SVHCs and what they are, and whether they'll even be in your product and why. And so there's some technical elements. We talk very specifically about impacts on your products. So today it's a bit generic, but normally we talk about your product. And we really explain the requirements and answer your questions. You'll have lots of questions. You'll have different stakeholders. People can be logged in all over the world for you. And we talk about your products and how it impacts you. And you get to leverage stuff we do for 60 plus other companies and a lot of communal knowledge and education. It's really helpful, but it's still very specific to your products. So this is kind of excerpts from a bunch of recent. The ones who have the service normally, you're going to recognize pieces of it. Some of it's really new. It's bits and pieces to show lots of things we do. This is pretty normal. So today, we're going to talk about the new substances up for consultation to become REACH SVHCs, the decision to be made in June. So we'll talk about those 5 substances, what they are, and whether they'll even likely be in your product. We'll talk about the regulatory change where the PFOA restriction is moving from REACH to POP and a change in exemptions and what that means. And then we'll talk quite a bit about RoHS, actually. There are 7 substances, followed by another 100 behind it, up for addition into RoHS, and a major step or recommendation step was made last week. We'll talk about the recommendations and whether or not these substances or which of these substances are moving forward to restriction under RoHS. And then probably the most common topic we got asked about is exemption status for RoHS. We're going to explain the exemption status for the ones in renewal and what that really means. Be really tangible. It's probably the thing we got asked about the most. I got a question about once a day on this one. So we're going to try to walk you through it. We're going to talk global cobalt regulation with this new reclassification in Europe as a carcinogen, and the fact that people are getting a lot of conflict minerals reporting templates for cobalt. So we're going to explain a little bit the differences of how cobalt is regulated, EU, California conflict minerals, to understand the differences. Prop 65, almost every month, we provide an update on Proposition 65. It's the most heavily enforced with over 200 prosecutions a month on average. So it's the most tangible, and we'll talk very specific. Sometimes it's also most interesting. Almost everything under enforcement are stuff that even as normal people you'll run into. And they'll talk about the Canadian prohibition of certain toxic substances. There are new substances being added to the restriction. In North America, almost all of our substance restrictions are under the Canadian prohibition. Until TSCA moves the priority substances through, most product level restrictions, physical product restrictions, you'll see with the Canadian prohibition. Right now, there's really short chain chlorinated paraffins, which is a recall issue in Canada, but it's a bunch of other substances about to go into restrictions. So we're going to talk about that. So the webinar is intended to be about 50 minutes. There'll be Q&A at the end. The normal version of this, your mics are open and we're doing Q&A throughout, having a dialogue and discussion about your products. It's one of the best ways we find to keep you up to date. But in this case, put your questions in the end and we'll try to get to as many as possible. So right now there are 5 substances in consultation to become REACH SVHCs. They're not REACH SVHCs yet. They've gone through a consultation phase and there'll be a vote and decision by the member state committee in, say, June probably a Zoom meeting or something similar. And then some or all of them will become REACH SVHCs in July. So we're going to talk about what they are and whether or not they'll even be in your product above 0.1% by weight in any component if they make the list. So the first one is 2-methyl-imidazole. It is a newer type of reproductive toxin. Not that the chemical hasn't been around a long time, but classification for reproductive toxicity has gone through a lot of phases. Like today, every single endocrine disruptor human health that's classified in Europe are all the same family. Either they or their metabolite are similar to estrogen. They have a phenol group, which I'll show in about 2 slides. It's basically a benzene, a hexagon, 3 double bonds, and an alcohol group, an OH, taking off of it. And it acts very much like estrogen. So every single one of those are endocrine disruptors with estrogenic effects because they mimic estrogen. This is a different family. This is one of the thyroid disruptors. It's a different structure. It's a pentagon with double bonds and nitrogen in there. It disrupts the production of the T4 hormone. And if you have a low T4 production, the T3, T4 hormone balance is hypothyroid. And in very low concentrations, this family causes hypothyroid. The most common one you run into this is benzotriazole. If you have dishwasher tabs and you get the one little ball on the top that polishes the silverware, benzotriazole is one of these family. It's a thyroid disruptor. Really shouldn't be in drinking water. This one is believed to be category 1B. 1 means known, B in animals, reproductive toxin, but it's not classified. So the medical device directives, we're talking REACH SVHCs, but there's super overlap with medical device directive regulation. The thing about medical device regulation is it doesn't control its restricted substance list. It has justification and labeling requirements for category 1, carcinogens, mutagens, and reproductive toxins, CMRs, and endocrine disruptors human health in materials in the fluid, gas, or invasive path. But they don't have a specific list. They use the classification elsewhere. So this one's not classified yet, therefore would not be medical device regulated. If this becomes an SVHC, it still doesn't affect medical devices because category 1 classification has to happen through CLP. So we'll talk one in a few slides. That's the way around. It's used as this chemical is used as a precursor to make a particular antibiotic. It's an intermediate. It's not even the final antibiotic. It's not used in physical products. I always review these again when they're published, but this one's extremely unlikely to be in any component in a physical product above 0.1%. It's an intermediate to eventually manufacture an antibiotic. It's pretty low risk. So even if it gets on the list, it's not going to be declarable. 1-vinylmidazole is a known category 1B reproductive toxin. Therefore, it's already regulated for medical devices in fluid, gas, or invasive path. It's an intermediate for polymerization. So it is really part of inks and adhesives that polymerize. It's an intermediate. It'll react to become a different chemical. So there's only trace amounts left in the final paint or ink or adhesive. However, for REACH SVHCs, the SVHC is for paints is not declarable in the paint for communication purposes. If a substance is still controlled by safety data sheet like a paint, the article communication requirements don't apply. Once it's painted on a product, then it does kick in, but the ink or paint, any SVHC in the ink or paint is measured over the weight of whatever's painted on. So we painted on this on a metal tube, any SVHC in the paint is measured over the weight of the paint and the tube combined. So as a trace remnant, because it's intermediate, of something that's a paint or an ink or adhesive, which is measured over whatever it's painted or inked or adhered onto, is very low risk for REACH SVHCs. So this one's also not expected to be declarable. So even if it makes REACH SVHC list, it's not expected to be in any component above 0.1%. It's pretty low risk. Butyl 4-hydroxybenzoate. So this is a classic endocrine disruptor, and it's being classified as endocrine disruptor human health. However, it is not already regulated as category 1B reproductive toxin. So strange thing here, if it gets regulated as an endocrine disruptor, it becomes regulated on the medical device regulation right away because the MDR does not control. As opposed to Cobalt, which is reclassified through a different regulation, CLP, as a carcinogen, it's 18 months before the new classification kicks in. So Cobalt is not regulated in MDR for 18-month period from its update in February, which we'll talk about later. This one nobody ever thought of this. So once it becomes endocrine disruptor, does it benefit from 18 months also for EU MDR? Maybe, but nobody ever thought about it, so they didn't write it in. This is a bit of a complicated one. Fortunately, today, it's really only used in cosmetic and personal care products. If it goes, it's not used in physical articles. We're going to revisit this as it gets closer to the decision date, but this is very unlikely to be in articles above 0.1% by weight. Now, this is a very classic endocrine disruptor, human health for estrogenic. It has a phenol group. The phenol group is that benzene ring, that six-sided hexagon you see there, with the 3 double bonds in it. That's a benzene. The OH sticking out of it is an alcohol group. So it's a drunk benzene, otherwise called a phenol. Estrogen also has a phenol. The active element in estrogen is the phenol. What it does is the estrogen doesn't make you female. It unlocks the estrogen receptor in the body, and that causes you to have a female body response, which endocrine disruptor. The phenol here is similar. So the rest of the structure does matter. It's not as effective as estrogen of creating a female response, but it can jimmy the lock. So estrogen is like a key to a lock, and it unlocks female aspects, as opposed to this one, which kind of jimmies the lock. It's probably about 10,000 times weaker than estrogen at doing it, but it will create some estrogenic effects. Just by eye, you can see the phenol group. Chances of not being endocrine disruptor to human health is really small. So it's very likely to get on. However, it's not expected to be in physical products above 0.1% because it's really cosmetics or personal care products, which is probably not a good place for it, realistically. A very clear endocrine disruptor, which we'll show another one in 2 slides, doesn't belong there. This one's a DIBUTYL. It's got a big, long, crazy name. It is a Category 1B reproductive toxin, so it's already regulated in EU MDR. It's a DIBUTYL, which are often fairly regulated in consumer products already. It's used in paint, but it's not an intermediate. It actually sticks around. It's used as a catalyst or a stabilizer, and it's usually still there. So it's quite likely to be in the paint above 1,000 ppm. However, like all paints, for SVHC purposes, once it's painted on the article, any SVHC in it, like this chemical, is measured over the weight of whatever it's painted on. So another good example is TGIC, which has been an SVHC forever and a day. It's one of the main solvents in powder coating. However, once you powder coat onto the aluminum piece, any residual TGIC, which is quite low because it's volatile, is measured over the weight of the aluminum piece it's painted on. So same thing here. The chance of this having residual about 0.1% by weight of whatever it's painted on is very, very small. So this one's also very, very low risk of being declarable. So even if it becomes an SVHC, this and the 3 previous one, all 4 of these, are not expected to be in any component above 0.1% by weight. And as part of this normal service, we'd revisit this as we get closer to the deadline. This one's a bit of a different case. This is resorcinol. It's visually clear-cut endocrine disruptor. It's a phenol. That's basically exactly what it is. It is actually the poster child for endocrine disruption. So when people compare DHP, or at least the metabolite of DHP, and BPA, and a variety of other endocrine disruptors, resorcinol is one of the comparators. It's a very commonly understood endocrine disruptor. It just has not been classified as such yet. It's a bit political because it's the main anti-acne cream. It's one of the main anti-acne cream ingredients, actually. I didn't put all the name brands here, but it's pretty darn common. It's also used as a hair and eyelash dye. I didn't know eyelash dye existed, but I'm told that's eyelash tint, which seems like not a good place to put this chemical. Considering it also the way it works as adhesive of formaldehyde, it's a very interesting thing to put in eyelashes and hair. It's basically wig glue, which seems a really exciting thing to put in your hair or eyelashes. It's also an intermediate to make azo dyes, which are pretty regulated to begin with, and it's fully consumed to make the azo dye. It's like the building block of an azo dye. It's one of the reasons why azo dyes aren't that healthy. It does have 2 physical product uses. One is a wood adhesive in combination with formaldehyde, which is, for most people here, is not going to be a big problem. Its other physical product is in aramid fiber reinforced rubber. Aramid's Kevlar. Kevlar reinforced rubber. It's basically one of the constituents between the Kevlar, or aramid, and the rubber. So you're looking at fiber reinforced rubber. Car tires, conveyor belts, fan belts. So for most products, this is pretty low risk. If you have one that has motion systems and moves vials around on conveyor belts, you might actually have this above 0.1%. So the previous 4 SV substances are very unlikely to be declarable in physical products. This one might be a very restricted outside of the wood adhesive. We're really looking at Kevlar reinforced rubber. And we still don't even know it's about 0.1% because it's never been regulated in this fashion. But this is the main risk area for resorcinol. If it becomes endocrine disruptor human health, it'll automatically get regulated in MDR. However, normally in a fluid path, you probably don't have a lot of conveyor belts and fiber reinforced rubber in the fluid, invasive, or gas path. But sometimes I'm surprised. So that's not a technical thing. So often, normally, the way the conversation really works is people ask questions. And you can ask questions here, but it goes in the control panel, and I read them off at the end. But normally in the update service, it's interactive, and people's mics are on. We have conversations about this in their product. And sometimes somebody asks one of the engineers, do we actually have any fan belts? And he goes, oh yeah, the R27.4 has one of these. And that might end up being the thing, the one part they look at for SVHC update. So whole update, and it might come down to after this discussion, we're looking up the fan belt in one product. And that's your SVHC update. So there's a lot of value in doing it this way, having a good discussion. One of the things going on is the PFOA is its restriction in REACH is moving to POP. And PFOA is regulated because it's a persistent organic pollutant or similar, and that's why it's moving over to POP where it more or less belongs. However, in the movement, the restriction for most products still stays at 25 parts per billion as of July 2020. And I'll talk about that in a moment. So most products. Medical devices had an exemption until 2032. Suddenly, implantables July 2025, and regular medical devices are in scope December 2020, which is a bit soon. There are a variety of other exemptions like semiconductor exemptions, which are still in force. One of the reasons why, now this is not likely going to hold. There is a notification came out today where ECHA and the risk committee are going to look at whether these exemptions make sense on these dates. So I expect these dates, the medical device one, to move from December 2020. It's not necessarily official, but the European Chemical Agency has been asked to revisit whether this makes sense. So we'll have more updates going forward. But as of today, still regular products. July 2020 is the restriction. It's REACH, not RoHS. It'll become POP soon, but they're both controlled by ECHA, basically the same thing. REACH and POP have more recalls than RoHS. This is actually a big restriction. You want to make sure you have no PFOA above 25 parts per billion. Now, where can you find polyfluorooctanoic acid? Well, one of the main uses when we look at California, which regulates it, is waterproof coating of fabric. It used to be Scotch Guard, not the current version, but the old version. And we rarely see it these days. Where we do see it is the phosphated version, PFOA phosphate salt, in ski wax. It's basically a fluoropolymer precursor. So it's basically coating your skis with Teflon, which kind of makes sense, but it's PFOA. And makeup, the makeup underlayer, especially ones that say silky, it's basically silky or smooth. And the reason it's smooth is basically Teflon or Teflon phosphate that you're spreading on your face. And water runs right off it, just like your frying pan. It's not quite the same, but it's a fluoropolymer, it's a fluoro-based material. It's also used to be used as the main processing agent in most fluoropolymers. It isn't mostly anymore, but 5 years ago it was pretty darn common. So they can often still have residual PFOA if they're made with PFOA. So typical fluoropolymers like PTFE or Teflon, FKM, Viton, PVDF, FEP. Now these fluoropolymers don't need PFOA, but they can be made with PFOA. So you have to make sure you have PFOA-free versions. Medical devices in particular, it's a really complicated problem for them because they use a lot of Teflon, especially in invasive situation because there's low reactivity, or fluoropolymer copolymers. So most products, you're looking at your fluoropolymers, PTFE, Viton, Teflon components, and ensuring that they do not, they're PFOA free. It doesn't mean PTFE is banned. PTFE can be made just fine without PFOA, but you have to make sure that's the case. And it's a restriction. This isn't like an SVHC declarable, it's actually a restriction thou cannot have at 25 parts per billion, very low concentration. Now they might revisit that number because as a test lab, we know it's the equipment detection limit, but realistically in most practical senses, with sample preparation, there's no way that's the measurement value. Moving a little bit quickly today, don't worry, but hopefully there will be recording. There's a lot of things to get through. Normally we do this, there's a lot of pauses and you ask questions and ask me to repeat myself, which is good. And there's a lot of semantics, and especially when I get to Cobalt, there's a lot of semantic details about why it's in scope, where, and what are the rules around it. Related to that, RoHS has the capability to add further substance restrictions. When it was recast in 2011, there's a delegated part that allowed the EU Commission through a process to determine whether or not any other substances posed a hazard to the recycling worker or the recycling worker's environment. If so, they had the ability to restrict it. So one of the key things about RoHS, it's not around user safety, it's around recycler safety and recycler environment safety. And this is because when WEEE was originally created, they realized they were poisoning the recycling workers with lead, mercury, and other things. And they couldn't implement WEEE without restricting those materials. And so originally these restrictions were in WEEE, and they're pulled out the last minute and became RoHS. And that's why RoHS originally was not part of CE marking, kind of was created spontaneously. When they rewrote it, recast it in 2011, they brought into CE marking, and they also made provisions to add more substances. The first four prioritized were the phthalates. So the four phthalates that were restricted in 2019 in most products, and in 2021 coming up from medical and control monitoring, were through this process. This is the next group, and there are almost 100 substances behind this. Yes, there are actually about 100 substances in a stage of this process. These are the first 7. So just to make people aware where RoHS is going. So the EU Commission has the power to determine, but they have a process to follow, and they hire an external consultant, and normally OICO, whether it's this or RoHS exemptions, to run the consultation with industry and then provide a recommendation on what to do. So on April 27th, they provided the recommendation, which is not necessarily the final word, but pretty darn close, of what to do with these substances, whether or not they should proceed forward to be restricted under RoHS. So I'll explain what came out of that. So this is an excerpt from their files, public information. So there are 5 cobalt salts. Now the cobalt salts are water soluble, and they're used to make cobalt plating. So if you cobalt plated part, they use usually one of these salts to make it. However, in the final product, it's cobalt metal. The reason it got to this point is until SCIP comes along, all the EU really has for substance use is the REACH chemical registration, where under cobalt salts, it said these salts are used to make many things, including electronics. Now they're used to make the coatings electronics, but they're not in the final version. The salts are water soluble. You basically put them in water, you run the electrodes, and they use that for plating. But the salt itself dissolves in the water. It's just the source to cobalt through the cobalt plating. And that's the same thing determined. It's not in the final product. Moving cobalt salts forward for the restriction made no sense. When SCIP comes along, a lot of this will change because a lot of the point behind SCIP is to provide at a customs code level where substances are, and to give them an idea what makes sense working on next. Up until now, they have to use the REACH registration information, which is for the chemical, not the physical product. They also use nickel salts, which are often used for nickel plating, which are super common in electronics. However, the final plating is nickel. The bath has water-soluble salts, which you put them in the bath, and then you plate the nickel plating. But the salt, even though it's used to make the nickel plating, isn't there in the final version. It's quite water-soluble. That's kind of the whole point. However, so they said, no, it doesn't make sense because it's nickel. But we would like to look at nickel and its compounds going forward because nickel is quite a strong allergen. And so that'll be kicked back into the line of the 100 plus substances coming through this process. So nickel will be revisited again sometime in the future, but nickel salts is not moving forward. And when will nickel move forward is unknown. It's recommended to move into the work list. Indium phosphide, a 3,5 semiconductor, it's like a high energy version of silicon. It's used to make diodes and certain power transistors, etc. Very low volume usage, fundamentally. It didn't make sense in their point of view restricting it because there's just not enough of it on the market. It's a trivial amount of weight. So they said no, the amount of actual indium phosphide in the market, because even the LEDs are normally indium aluminum gallium phosphide, and which is a different material. So they said no, just for the volume, just restricting it did not provide any significant health benefit. Beryllium and beryllium oxide, they're airborne carcinogens. If they get up in the air and you inhale them, which for recycling work, when they grind up a product, would seem to be a problem. They said no, it didn't actually make sense. For some reason, they didn't have enough justification of airborne nature. When you grind up an electronic, I think you would, but they did get a lot of recommendation to restrict it in contact brushes and electronic motors. As opposed to brushless motors, use one with contact brushes because it can spall and put beryllium up in the air. It's a really weird situation. This would be an application-specific restriction for beryllium and contact brushes, which doesn't belong in RoHS. RoHS is normally a broad restriction with application-specific exemptions. A application-specific restriction would normally go in REACH. This would make much more sense in REACH, banning beryllium in contact brushes in electric motors. I'll get to MCCPs and tetrabromo bisphenol A in a minute. ATOs and antimony trioxide, they couldn't justify moving it forward. It in itself doesn't provide much of a risk, but it's extremely high volume substance, maybe the highest volume substance of all of them here. It's the main synergist for halogenated, chlorinated, or brominated flame retardants. So for halogenated, bromine, or chlorine-related flame retardant to operate properly, someday we'll have a longer explanation. The bromine or chlorinated or the halogenated flame retardants are gas phase flame retardants. As they burn, let's say the chlorine plus, which is a chlorinated one, the chlorine pops off. It then will, during the fire, it'll then react or collide with the hydrogen radical produced from plastic burning, and will damp down the energy released from the reaction so it doesn't go back into the plastic and continue burning. This works out because the chlorine or bromine atom is much bigger than hydrogen and can damp down its excited energy from the fire. Antimony is even bigger than chlorine or bromine, and then it collides or reacts with the chlorine or bromine and damps down the energy further. So antimony trioxide is a very effective way to make the flame retardants work more. And the average electronic product, especially ones that plug into the wall, we have usually dozens of components in any individual product that use antimony trioxide. It's kind of important. As I said, no, by itself, it doesn't make sense. However, we should revisit it in combination with halogenated, chlorinated, or brominated flame retardants in the future. So it got kicked down the road. The two that they recommend to move forward were medium chain chlorinated paraffins, MCCPs, and tetrabromo bisphenol A. MCCPs are the medium chain chlorinated paraffins. Short chain chlorinated paraffins are already banned. And in effect, that really bans medium chain anyways. We give them a lot of stats. We test for this sort of stuff all the time. Chlorinated paraffins are not regulated by chain length. They're regulated by chlorine content. So when somebody thinks they're using MCCPs, they're also using SCCPs. And so the product's already regulated under SCCPs. We'll talk about that one again in a second. They recommended that one to restrict, and we'll explain the impact on the next slide. Tetrabromo bisphenol A is one of the main constituents to create FR4 circuit boards. However, it fully reacts, and it's no longer tetrabromo bisphenol A in a circuit board. But they move forward to restrict it in a particular situation, which is going to be a bit tricky. So I'll explain all this. Two are moving forward. It doesn't mean restriction is imminent. More work has to be done. Eventually, the final point is when the EU Commission accepts the recommendation, and then it gets published in the official journal of the EU. But we'll very likely see MCCPs and tetrabromo bisphenol A added to RoHS in the 2021-2022 timeframe, likely coming in restriction 2024-2025 range. So we're looking at very likely two new restricted substances RoHS come 2024 or so. Substance dose, MCCPs are only found in products in conjunction with phthalates. What the chlorinated paraffins do, they're a secondary plasticizer. It doesn't mean they're a weak plasticizer. What they do is they enable the orthophthalate, DHP or DINP almost exclusively, to integrate better with the PVC. And it's also a lower cost than orthophthalates. So it's a cheap way to make phthalates more effective and consistent plasticizers. As we move away from DHP, it reduces their use a lot. However, they're still used in DINP, which we see in power cords all the time, which is regulated in California, but not in Europe. As you move away from orthophthalates, as companies move to tetraphthalates, the chlorinated paraffins go away anyways. But this is basically taking the short chain chlorinated band and moving it up to encompass more substances, which to get rid of orthophthalates, you'll get rid of it anyways. That's its only use. Tetrabromo bisphenol A is only being restricted in additive form. So one of the other monthlies or quarterlies we do, we do describe the difference between additive and reacted flame retardants because it changes their regulation dramatically. Swedish flame retardant tax being the most specific, but in general, the additive flame retardants get banned, the reacted ones do not. The difference is an additive one is one that's added to a plastic, like tetrabromo bisphenol A is added to ABS or HIPS, high impact polystyrene. But they don't become part of the ABS. They're not attached. They're kind of like touching or dating the ABS, but they're not married to them. They could leave at any time, and they don't take anything with them. They don't get half the house. And if we test for it, the tetrabromo bisphenol A is usually measured because it's not bound to the ABS. It's just there. Tetrabromo bisphenol A is one of the main substances to make FR4 circuit boards. So one of the layers is brominated polycarbonate. So polycarbonate normally is bisphenol A, phosgene, repeating chains until it hits a tert-butyl terminator, which limits the chain length. Otherwise, the chain would be super long and the thing would be really brittle. Tetrabromo bisphenol A is bisphenol A with bromines attached to it. It literally plugs in where BPA plugs into the polycarbonate chain. So it becomes brominated polycarbonate. It becomes a different chemical. If we test for it, as long as we're using chemicals that don't depolymerize or change the chemical nature of brominated polycarbonate, it's not, we don't measure it. It doesn't come out. It's married. The reactive ones are basically married. The only way you could get it out is you have to break them up, and they take pieces with them. They're not just dating or in contact, they are integrated. They're part of the polymer chain. You have to actually break the polymer chain to get it out. And in that case, they're not very dangerous. The additive ones can come out, and that's why they're dangerous. So it's a bit of a strange thing. They're looking at banning it only in additive form, in which basically the way it would be used in ABS or HIPs. In the old days, very rare nowadays, but not in its most common usage is a reacted flame retardant in FR4. But this is going to cause so much confusion for people, especially when you look at the safety data sheet and go, hey, look, for the original F4 chemical, it had tetrabromo bisphenol A. Yes, but now it fully reacts and it's brominated polycarbonate. Like we see right now, the SVHCs, hey, borosilicate glass is made from boron trioxide. Well, the main thing we run into is actually aluminum borosilicate glass, which is E-glass, which is the embedded glass in most connectors. And if you put it in the wrong material, solvent, like a chlorinated one, it'll actually cause it to break down. You start measuring boron and think you have an SVHC. Complicated problem. You have to use the right solvent, but if you use the right solvents, it doesn't come out of FR4. It would come out of ABS and HIPs. So these two look like they're moving forward in one shape or another to restriction, likely update in the 2021-2022 range, and likely seeing its restriction in the 2024-2025 range. And there are literally 100 other substances behind these going through. And so as part of this, we'd also update companies on where they're at. Right now, we don't want to talk about the real imminent ones. The next ones won't even go, there's another dozen or so going through this consultation probably next year. Now, the thing we're asked about all the time is exemption renewals. It's very complicated. It's very semantics based. We have a lot of trouble with Asia, which looks at the chart in the legislation. They see 7C1 expires July 21st, 2021. It's what it says in legislation. That date isn't the expiry date. It's the date it would expire if no one submits a renewal application at least 18 months in advance. If a renewal application submitted 18 months in advance of that date no longer matters, and the renewal process takes over the exemption deadlines, like it did the last time 7C1 was renewed. So even though it's written there, which has caused a lot of challenges in a lot of places, people are like, it's right there in the legislation. Yeah, it's kind of really complicated semantics. That's the expiry date if no renewal is applied for at least 18 months in advance. If it's applied for, the renewal process takes over the deadline dates. And so all of these exemptions have had the renewals applied for. So these all have 2021 deadlines of some sort. The renewal application has been submitted for all these, which means what is written in the legislation is no longer their expiry date. They're controlled by the renewal process. If an exemption has a 2021 expiry date and it's not one of these, it'll automatically expire on its listed date. But all of these are now controlled by the renewal process, and the expiry date in the legislation no longer applies. Short summary. The current expiry date in the legislation for the ones that have a renewal are no longer relevant. Expiry is controlled by the exemption renewal process. The earliest they can expire now is 18 months, more or less, a little more complicated than that, but not to talk a couple paragraphs. So basically 18 months from the decision on renewal. So once the EU Commission makes a decision on whether they're not going to renew it, if they decide we're not going to renew it, it still lasts for about 18 months. So for example, there's probably going to be a consultation by OICO, and in their presentation on April 27th, when they talked about what they're doing about the 7 potential substances for RoHS restriction, they also talked about the criteria for the next stage of this. So the second half of 2020, we expect to see most of these exemptions start to go consultation process. OICO will probably make recommendations mid-2021 on whether or not they should be extended or in what form. It might be longer. There's a lot of exemptions to go through. And the commission, probably at the earliest, will make a decision on the renewal at the end of 2021. So the earliest any of these can really expire is about mid-2023, most of which will be renewed in some fashion. So, for example, what do you do? Okay, good question. What to do? Nothing to do at the moment. You're going to get questions out from suppliers. When in doubt, we can help. Our customers saying, you're using this exemption, it expires in July 2021. What are you going to do about it? Well, it doesn't actually expire anymore. There's a renewal in process. I know it says in the legislation that date, but the renewal process now controls it. We, Claigan, monitor this all the time. So anybody doing this service, we keep you up to date. We talk about a lot of the subtleties. What are the risks? Most should be renewed, but there might be narrowing of scope. Sometimes, in particular where the exemption is not needed. So, for example, a good example of this is they have a mandate basically narrow the scope as much as possible going forward. And a good example of that is 7C1, which used to be Exemption 5, basically lead and glass of optical and electronics, which eventually became Exemption 7, lead in electronics, and then 7C1, which is lead in glass and ceramic. 7C, lead in glass and ceramic in electronics, and then it became 7C1, which is lead in glass and ceramic in glass and ceramics and electronics, except for ceramic capacitors, which have their own exemption. What it's really used for is three different things. It's used for it's for thick film resistors, it's used for diodes, and it's used for PZT, or piezo materials. Piezo might go its own direction. It's a different material type. We could see the scope narrowing to actually talk about thick film resistors and diodes and piezo materials as two separate exemptions. That would be narrowing the scope and meet the requirement, but really continuing on every use of 7C1 anyways. It just gets rid of anything anybody didn't ask for. So they asked for thick film resistors, diodes, and PZT, lead zirconate titanate. Those ones specifically might continue, but they'll get rid of any generic usage. This is that kind of narrowing we expect. We also expect some clarifications, hopefully. Some of the exemptions are an absolute dog's breakfast mess. One of them is 6A, which is lead and steel. And it's not the lead and steel and machine parts that's a problem. It's the hot dip galvanized. Because it's kind of a hand wavy exemption. It's something like 0.2, can't remember the exact number, lead. But it isn't, when you measure it, it doesn't end up 0.2. It's much, much higher. Because what ends up happening is the material is hot dipped into a zinc lead bath. And the outer layer is really heavy lead. Upper closer to 0.5% to 1%, way above the exemption, but there's nothing inside. And supposedly it's measured over the weight of the entire metal, which is kind of a bizarre way. So if you try to measure it normally, you'll get a sky high result, especially if we do surface measurements, because the surface is very leaded and the interior has no lead. And you really need a better way to handle it. And the test standards don't really handle that problem, especially when using X-ray fluorescence. You have to have internal processes to handle it. So that was RoHS. So again, the exemptions, so on and so forth, are going through renewal process. Any deadline for them is not applicable anymore because their deadlines are controlled by the renewal. So we said we're going to talk about cobalt regulation. A lot of what triggered this are two sort of events. One is the reclassification of cobalt in Europe as a category 1 known to cause B in animals carcinogen. And it's published in the official journal in February. Now, it's published under the Classification, Labeling, and Packaging Regulation, CLP, but it doesn't come into effect until September, depending on your point of view, October of 2021. So even though it's reclassified, the classification doesn't kick in until 2021. A couple side effects of this is EU MDR, Medical Device Regulation, does not control its restricted materials list. It uses the classification process. So once this becomes a Category 1B carcinogen, it's regulated in invasive fluid or gas contacting paths. And the specific problem is stainless steel. Medical grade stainless steel often has cobalt between 0.1 and 0.2. It's actually probably the most common situation. It doesn't have to be there, but normally is. And if it's above 0.1, it'll require a labeling and justification, which is kind of strange for stainless steel. Because cobalt is a problem, but not as cobalt. It's carcinogen as cobalt 2+. And a cobalt 2+, like nickel 2+, reacts to human proteins and creates a hybrid metalloprotein hybrid, which has a lot of negative effects. In stainless steel, if it doesn't dissolve, it's harmless. But by rule, it's by percentage. So I know MedTech, which is the medical association, is working with the EU Commission and trying to figure out a solution. Otherwise, they're going to have to label and justify a carcinogen in their medical stainless steel, unless they can get the cobalt below 0.1, which is a bit tricky. So that is something is in flux. In absence of anything else, come September or October of next year, medical device with stainless steel with cobalt above 0.1, which is pretty darn common, will have to label and justify the carcinogen for cobalt. It's also, now it's not regulated in other products. The fact that the category 1 carcinogen does not make it regulated in normal products, but it basically opens up the door for it to become a REACH SVHC in 2021, which is quite likely. So now that it meets the category 1B carcinogen category, it's very likely to become a REACH SVHC next year, which will bring cobalt steel in, of course, in play, but also stainless steel. So this is one thing we have to monitor. This will probably change some regulation. Now, cobalt is already regulated in Prop 65 in California, but it's regulated differently. It's this cobalt metal powder. It's only regulated in powder or the inhalable form. So stainless steel, which you can't inhale, I hope you can't inhale, shouldn't be able to inhale, does not count. This is cobalt metal powder. It's cobalt powder, inhalable powder. So it's a Prop 65 carcinogen as a metal powder, not as a stainless steel bar. So cobalt's regulated here, but quite differently. The stainless steel bar is not regulated here. It's the metal powder, inhalable. It has to be inhalable. And you don't really want to pick up, I don't think you can pick up your stainless steel spoon and try to inhale it up your nose. That's a weird visual right now. Moving on. The cobalt reporting template, where another place a lot of people are seeing cobalt, is it's like the 3TGs or tin, tantalum, tungsten, gold, conflict minerals reporting. Same sort of form, but it's not part of a regulation. It's not part of Dodd-Frank. It's just a lot of companies had lawsuits against them related to the conflict sourcing of cobalt, and the industry, through the Responsible Minerals Initiative, have pushed forward doing data gathering on the responsible supply chain of their cobalt. Now, this is also different. It's only intentionally added cobalt. So cobalt steel, well, it's actually cobalt steel that has a minimum amount of cobalt in it. Stainless steel does not have a minimum amount of cobalt, or normal stainless steel. It has a maximum amount of cobalt. If it is a maximum, that means the upper limit, but it's not required. If it's not required, it's not intentionally added. So cobalt and stainless steel is not part of this. Cobalt steel is, cobalt and batteries is, cobalt magnets are, because it's part of what they are, but stainless steel that has cobalt up to 2% as a maximum, but no minimum, is not in scope. So it's regulated quite a bit differently. This is an industry initiative, very similar to tin, tan, tungsten, gold, that a lot of people are seeing. It's not a legal requirement, but then again, most companies doing reporting to Section 1502 conflict minerals are also, it's not a mandatory requirement, it's a customer requirement. Prop 65, this is one of the things we talk about every month. Moving on here, it's the most prosecuted. So in March, on average, about 200 prosecutions a month or prosecution notices. This is 390, which is a bit high. Physical products are pretty well dumbed down to two very consistent Prop 65 prosecutions: phthalates and flexible PVC. So this accessible, flexible PVC that you can touch. The phthalates come out in the sweat oils in your fingers. Phthalates actually dissolve in the oil or the sebum, sebaceous gland, in your fingers. Like, you know, you leave fingerprints around, that's from the sweat oils. It's from the sweat oils in your fingers, and the phthalates dissolve really easily. To the point where you touch a power cord made with DINP, you will get, in that one touching, more than your daily dosage. And the way the exposure works is the EPA says the average person touches their mouth about 8 times between hand washing. The medical industry actually says it's 23. And because of that, 50% of what ends up in your fingertips ends up being ingested, either through hand to food or hand to mouth action. It kind of explains a lot of problems people were having with COVID originally, where it's the hand transfer, often from handshakes, to then eating food or otherwise transferring it to the face where it can be inhaled. This one's ingested, it's a little bit different, but it gets finger contact. Half of what ends up in your fingertips ends up being ingested, according to the EPA. So even one touching of a power cord, enough it will dissolve in the sweat oils. We did some measurements. It's just spectacular how easily it dissolves in sweat oils. We'll get on your fingertips that even half of it is on your fingertips will be well above your daily exposure limit. and lead. Now, most of the lead prosecutions are in food, which I'll talk about in a second, but in physical products, mostly it's lead and brass. Lead and brass, especially machine brass, if you touch it, the sweat acid in your fingers will pull the lead right out. It's kind of neat. The phthalates come out in the oils. They're organics. They dissolve in oils. The metals come out in the sweat acids. Your sweat kind of is a lot of water, but it's also weak acid, and it's got oils in it. So it's actually not a bad solvent. So it pulls the lead out of the brass. It also pulls it out of painted ceramic. So when you have glazed ceramic, like ceramic tiles, the kiln process would destroy most organics, so most color are metals. And if it's lead, like it's a blue or green one, you can just touch it and the lead will come right out in your fingers. Also, they say leather, but it's really artificial leather, not real leather. Artificial leather, which is vinyl, which is PVC. Flexible PVC is not stable over temperature. It needs a stabilizer, otherwise its durometer or softness will change with temperature. And classically, the actual stabilizer was dibasic lead or lead stearate, lead soap. More recently, it's zinc stearate or zinc soap. But even some cheap PVC, we still see lead in PVC all the time, and it's because it's the stabilizer. And that's like 25 parts of brass and ceramics and artificial leather. The other 128 were food, dominated by balsamic vinegar. Balsamic vinegar, they have a lead problem, which is not surprising because it's acidic. And if any of its fluid processing goes through brass components, which is pretty normal at the connectors, the vent pieces, the acid will literally strip the lead right out of it. Lead is very soluble in vinegar. So the balsamic vinegar, if it touches anything brass related, it will just strip the lead right out of it. That's probably where it's coming from. Cadmium are mostly red and gray seaweed, red and brown seaweed, which could be why it's reddish, because it has high uptake of cadmium. Mercury is mostly canned food, mostly canned baked beans. The PFOA is in ski wax. Previous prosecutions are in makeup. Ski wax is basically a fluoropolymer, really phosphate, that they apply to the bottom of the ski. It's like putting Teflon on the bottom of the ski. It's quite slippery. And BPA. BPA 1's in polycarbonate. There is actual limits now for BPA in wearable polycarbonate for Prop 65. It's only wearables. Casual contact won't release enough BPA. But polycarbonate, they've ruled what the BPA limits are in wearable polycarbonate. So there's now threshold limits. Very rare prosecutions and only for wearable polycarbonate. Variety of other prosecutions that don't affect physical products. Acrylamide, it's the brown or black that gets created when you toast something. Arsenic, it's related to rice and herbs, especially oregano from Asia. A number of these come from places where the soil has soluble arsenic and the irrigation waters bring up the arsenic, and rice and oregano and some other herbs have a tremendous ability to uptake arsenic. Carbon dioxide is from stuff you burn, like wood, and then a variety of chemicals related to heart medication recalls. In terms of physical products, you're looking at lead, in brass, and really phthalates and flexible PVC, with the occasional wearable polycarbonate. So very, very limited, but still hundreds of prosecutions a month for those. If you have accessible flexible PVC, you really don't want an orthophthalate in it. It comes right off in your fingers. Unless you have a warning. Again, Prop 65, you can remove the substance or place a warning. Both make you comply. So usually we also have more discussion about their product, and we talk about their power cord, or it's a third-party brick they buy and what they should do with it, and so on and so forth. So normally this is very interactive. Your mics are on. We discuss your products and your situation. Today, feel free to put questions in the control panel, and I'll get to as many as possible in a minute. But normally this is much more interactive. The real version of this is very interactive. Canada is changing the prohibition of certain toxic substances, which is really the source of all restricted materials in North America. When TSCA works through the priority substances, there will eventually be U.S. restricted materials, but today, any restricted materials we deal with in North America are through Canada. Either short-chain chlorinated paraffins, which are very common in cheap PVC, and that's the main source of recall, or BNST in lubricants, which is a more limited application. There are 7 substances, PFOA, PFOS, another long chain fluoropolymer being added. They're all planned to be published at the end of this year as restrictions. Now, things might be delayed, but that's the current plan. Going to effect likely 2022. Technically, the way it actually works is the second they're published, they're restricted, but then there is an exemption for products for like 2 years. So we were to write it saying, hey, everything's banned. It's now banned in all products immediately as of the drop of this writ in the Canadian Gazette. However, products being placed in the market until the end of 2022 are exempt. kind of a backwards way to do it, but I use it for national motto here in Canada, unnecessarily complicated. So you're looking at new restricted substances, and there are three that are kind of a big deal. One is DIBUTYL, which is already an RoHS substance. So if you're RoHS compliant, then this isn't going to be a problem. It's been restricted in RoHS forever and a day. It's really useful in thin plastics. It with antimony trioxide is a wonderful flame retardant combination with thin plastics like heat shrink. But it's already banned under RoHS, so it shouldn't be a problem. Of all the PBDEs banned under RoHS, this is the only one we ever see, and quite intermittently. Dechlorium plus, on the other hand, which is a REACH SVHC, this is the first time it's being restricted. It has the same application, basically, as DIBUTYL. It's for thin plastics. It's very similar if it's chlorinated, it's brominated. We see it in nylon connectors, like the end of little hookup wires, the little connector that's got very thin nylon walls between each one of the fingers, or heat shrink or EBDM. Heat shrink and EBDM are the most common sources. If you buy heat shrink, where responsible companies are declaring SVHCs, it's one of the most common SVHCs, the Dechlorium plus. It'll be banned in Canada probably in the 2024 timeframe. We do see it in heat shrink, polyolefin blends. It is a REACH SVHC, but it'll be banned in physical products probably by the end of probably sometime in 2024, probably start of 2024. But we'll see. We won't know until the end of this year. DBDPE, extremely common substance, not otherwise regulated, so nobody knows how often it is. If you gather full material declarations, awesome, great on you, it won't be in there. This will be buried in the plastic. You'd have to regather the data anyways. It's banned in manufactured items at 0.1%. It's expected to be published by the end of the year, give or take any delays due to COVID, et cetera. Probably banned around 2024. It's very common. It's like one of the most common replacements for DIBUTYL. When we test for it, the same materials that are risk for DIBUTYL, we find it about 1 in 3 times. It's very, very common. It also works with antimony trioxide. It's basically the drop-in replacement for DECA. It's got it's a very simple 10-bromine substance. It's fantastic for heat shrink and small connectors. Again, helping them pass the candle test, which is very difficult for thin plastics. They need kind of high halogen count. Flame retards like this with antimony trioxide. One of the biggest problems is it's not otherwise regulated, so nobody knows they have it. And this is going to be a redesign problem. You have something that plugs in the wall, chances are you use it. It's a really common flame retardant. This is looking like an RoHS level redesign, probably for products in the 2024 range. And because people don't separate well the Canadian and US restrictions, it's going to probably affect all of the North American market you sell into. It's also on the path for restriction in Europe. It's just a little bit slower. These are all coming from, so everything that's restricted in Canada are persistent organic pollutants. It theoretically could restrict carcinogens and reproductive toxins, but for a variety of reasons, in both the US and Canada, the bar to prove human health hazard is very high, probably unnecessarily high. To prove bioaccumulant, it's far more straightforward. So basically every single restricted substance you see will be a bioaccumulant. That's also been agreed upon in the Stockholm Convention, and you'll see in Europe under POP, the persistent organic pollutant regulation also. They might regulate them a little bit differently, but in general, if it's restricted in one, it'll be restricted in the other. Anything you see in POP will end up here. Anything you see in prohibition contains certain toxic substances will end up in POP. So at least there's some commonality between Europe and Canada here because they're following the same UN playbook. But in terms of North American market, this is going to cause redesign, especially of electronics that plug into the wall. It's a very common flame retardant, but it's not regulated up to now, so nobody knows they have it. So again, just explain today was once a year, we sit there, we do excerpts from our monthly and quarterly update services, get to have a flavor of what we do. Really recommend it. We just sit down once a month or a quarter, depending. Medical, it's more and more monthly because their world's changing so fast. We sit down and we explain the changes in restricted materials compliance requirements and technical details, like we talked about the REACH SVHCs today. Are they even going to be in your product? At the end of the day, when you do the SVHC update, you can try to gather all the data from your suppliers, and when a new update comes, good luck on you. It's not going to go very well. However, if it comes down to, wait a minute, at the end of the day, all I care about is whether my fan belt, my one fan belt, has resorcinol. That's the sum and total of my update. Yes. Okay, that's manageable. It's far more tangible. We talk about the impacts on your products, try to be very specific. And we try to really explain the requirements, answer your questions. You also benefit from all the questions everybody else in the industry asks. Because people who do this all the time and have a lot of dialogues. And there's never a stupid question. And almost anything that happened to you has happened to someone else. And we explain it. One of the most common ones is here's the list of chemicals I'm asked for by my customer. Okay, this is really this. This is what it really is. One of the worst things in the industry is somebody gives you a list of chemicals to comply to. It's not helpful. It's just what's the regulation, which has all the methods and exemptions and all the details. So what do you need to quote? Of course, we're a major laboratory. We do lab testing all the time. If you want something tested for restricted materials, which is really the best way, especially to do compliance for new designs, it's just the easiest way to comply to everything. Just send us a picture or web link, and we'll be able to quote. We do this all the time. Like, it's a very simple process. Monthly, quarterly update, just contact us. We'll send you the details. We do this a lot. We do this for 60 plus companies on a regular basis. It's a very, very effective. It's very cost efficient because we do so much of it. It's not like we're doing a big research project for you. You're benefiting from everybody else's communal knowledge, but specifically formatted for you and talk about your products. Definitely one of the most popular products by a lot right now is our SCIP web demonstration. My goodness, people try and make their lives difficult with SCIP. You have to do it, but there are easier ways to do this. And we sit down with one of your products and create the declaration and the templates for you. This is how it's done. A lot of people are looking at bomb rollup. It won't work. It's not just, everybody's, oh, I have to make it all attached. No, it's legally won't work. Because where a lot of your declarables are, if you roll up your bomb, will be, hey, it's the power supply I bought. You can't declare the power supply. That's a complex article. You have to declare the components in the power supply. It's the law. It's one of the few parts that actually is the court case law. You can't declare I have lead in my power supply. No, you have to say I have lead in my high temp solder, in my diodes, and I have lead in my brass. So roll-ups don't work, and it's just too painful anyways. If you trust supplier data, REACH SVHC, you're in for a surprise. When we test products and we compare them against supplier data, except for lead and brass, they're virtually not related. Supplier data, for one reason or another, and there's a lot of misinterpretations, just isn't right. There's a much easier way to do it, much less painful way to do it, and we'll go over it. So this is a very good, you spend a couple hours of your time, you get to see probably the most hands-on thing you'll ever get to see in your space, where we take your product apart, and we actually point to things, and we'll tell you, not only around REACH, but how this applies to RoHS and Prop 65, and how this material, what the risk material is, and what you're gonna control. And be really, the web demonstration is amazing because we have multiple cameras, we can actually show very small things and really make it tangible for you. And then show you the much easier way to do it in Excel and then the iEuclid forms. So very popular. Get to everybody's questions now. Again, if you have any questions, feel free to submit it in the control panel. Resource, what's the level of risk as intermediate UV stabilizer of plastics? It's used to make UV 320, which is our REACH SVHC, and it's consumed in the manufacture. If you actually look at the two, you can see where one becomes the other. It's an ingredient to make the UV stabilizer. So it's the UV stabilizer itself will often be only 0.5% in plastic, and then whatever residual amount of resorcinol will be a couple ppm, like very small numbers. Is there any updates and postponements to the implementation of SCIP? They're going to look at it, but there's not any anticipation for them to publish blanket postponements for anything in 2021 yet. And this one's a bit complicated because ECHA controls what ECHA controls. This is in the laws. It's controlled by the commission. That one has to go through the whole parliament and commission. Chances are there'll be some level of delay for SCIP, but they're not really getting around to the 2021 ones right now. They're only worrying about the mid-2020 versions. Hi, Bruce. What about the other RoHS regulations around the world, like Turkey and Japan? We definitely talk about those all the time, China, Turkey. Turkey is interesting. They'll accept the European, but legally what's required in Turkey is usually one phase behind because Turkey doesn't have a specific treaty with the EU to follow the same rules, but they want to sort of become part of the EU, and they want to use CE. So they have to individually implement each regulation themselves, so they're usually far behind. So like for RoHS in Turkey right now, we not normally have the phthalates in it. So we talk about each one, but they're often behind. So anything that gets added, like phthalates or eventually MCCPs, EU RoHS would not necessarily apply to China yet or Turkey yet because they have to, in their own legislation, implement it. As opposed to somebody like Norway, which is not part of the EU, but has a treaty with the EU to follow the same CE marking rules, so it would apply to Norway. It's kind of an interesting difference. What's the typical cost of quarterly update webinars? Just contact us. Like the total for the year is a couple $1,000s. Like it's not much. Just contact us, reach out, and we'll definitely provide you all the details. There's a couple different options too. Monthly is the biggest difference between quarterly, and it's really, and a lot of companies start with monthly, and sometimes they move to quarterly if they think they're getting enough. But there's so much changing right now, and there's so much use and repetition to a certain extent. A lot of companies are with us on monthly level, but just contact us, reach out. We'll get back to you right away. It's a great question. Pleasure hosting everyone. Sorry, I'm just going a bit over time. If you have any contact questions, just feel free to contact us. It's been a pleasure hosting everyone again. So it's kind of fun. We really do like talking about people's products. It's really helpful. You get to benefit from a lot of things that other people have learned, whether ourselves, but we talk to other companies and say, hey, we are actually on the meeting about this, and this is how we talked about it, and this is what we're going to do next. Excellent. And how to go forward with that. So pleasure talking to everyone again, and I look forward to talking to everyone again soon.